Hello, dear learners. I hope all of you are doing well. So, today I am here with yet another topic on this very particular course on Advanced Statistics in Education on SWAYAM platform. So, I, Dr. Noora Abdul Qadir, is here with a new topic on t-test and its types. So, here I am with yet another parametric test, that is t-test and its types. So in the last classes, we discussed about what is t-test and what are the basic assumptions of t-test also. So let's have a more in-depth exploration with respect to what are the different types of t-test. Okay, let's go. As an introduction, I have kept a few sentences for your perusal. That is, it is developed by William Seeley Gossett in 1908. That is, t-test is being developed. That means two away from the time immemorial, isn't it? By William Seeley Gossett. And we all know that it is used to find out the significant difference between the means, and also the condition is applied when the population standard deviation is unknown, but we know the standard deviation of the sample, isn't it? So that is just an introduction with respect to the t-test. So let's move on to the purpose or the uses of t-test. It is used to compare one group with a standard value, that we know that it is used to compare the group means with the standard value, and also it can be compared with it can compare the two independent groups. Along with that, it compare the same group before and after the treatment. Just like that, in the case of an experimental test, you can compare the two groups after the treatment, that is the pre-test, and then give the treatment, and then the post-test. It is also used in the field of education, psychology, and also in social sciences. So these are just a few purposes and uses of t-test. Assumptions of t-test. Assumptions of the parametric test, we know that those assumptions will be much more applying with that of the assumptions of the t-test. We know that independent observations are required. Data should be continuous, that is in the interval or in the ratio scale. We cannot go for the ordinal or in the nominal scale, and also the data should follow a normal distribution, and the samples are usually randomly selected over here, and equal variances in the group. So these are the general assumptions with specific to that of the t-test. I repeat, independent observation should be there, data should be continuous, it should follow normal distribution, sample should be randomly selected, and equal variances in the group. So these are the basic assumptions with respect to the t-test. Now, types of t-test. Today we will be focusing on these three, that is the type of t-test. One is one sample t-test, compare the sample mean with the population mean, and the other one is the independent sample t-test, compares the means of the two independent groups, and the next one is the paired sample t-test, which means it compare the same group before and the after intervention. Maybe it's not clear, right? So let's move on to the example. Don't worry. One sample t-test, isn't it? See, for example, a teacher wants to know if her student's average score in an English proficiency test, isn't it? That means the average score in an English proficiency test is significantly different from that of the national average score. That is, the national average score is 70, and whether it is significantly different from that of the student's proficiency in English average score, that is 70. Okay, so here to test whether the class mean differs from a known population mean, that is where it is known as a one sample t-test. Okay, here there is only one sample over here, the student, then the proficiency test of the student, it is being compared with that of the average mean score of the population. Such kind of test is known as the one sample t-test. Next one is independent sample t-test, which we usually do. Independent sample t-test. See, for example, a researcher is comparing the average mathematics scores of both boys and girls. Boys and girls, independent group. Okay, so here in a school, to see if there is a significant difference in the performance between the two groups, that is whether the performance in the mathematics between the boys and the girls after taking their achievement score in mathematics, whether these scores have significant difference with respect to the male and the female, we are checking. That is independent sample t-test. So here the purpose is to test the difference between the means of the two independent groups over here. So is it clear? That is independent sample t-test. Now let's move on to paired sample t-test. And what is it? See, for example, an instructor measures the student's performance. An instructor is measuring the student's performance before and after attending a remedial English program. Okay, there is one group, isn't it? One group. There is no two group. There is only one group. But here, the teacher is assessing the performance of the English intervention program before and after. That means the performance before and after. The teacher is giving a pre-test to see, for example, on English language proficiency, and then the teacher is giving them English language proficiency or remedial program, and then the teacher is conducting the post-test. And that pre-test and the post-test are being compared over here. Such kind of test is known as the paired sample t-test. So what is the purpose over here? To test the difference between the two related, that means paired measurements on the same participants. That is what known as the paired sample t-test. So now with the example, I hope it is clear. What is one sample t-test? Independent sample t-test and also paired sample t-test. Okay. Now let's have an example on the formula of the one sample t-test. That means here one sample t-test t is equal to, that means the sample mean minus the population mean divided by the standard deviation divided by root of the sample size. This is the usual equation that we are using for the one sample t-test. Here there is a sample mean, we have the population mean, sample standard deviation, and we have the sample size of the sample size of the population. We have the sample size over here, that is the n. Here by using this particular formula, we used to calculate the one sample t-test. And now what is the formula of the independent sample t-test here? Mean of sample 1, that is over here, and mean of sample 2, that is over here, divided by the pooled standard deviation and the root of 1 divided by n1, that is the sample size of the group 1, and n2, that is the sample size of the group 2. Here, by using this particular equation, we used to calculate the independent sample t-test. Paired sample t-test, that is calculated by t, that is the value of the t-test, that means means of differences divided by standard deviation of differences, which is divided by the number of pairs, that is the root n. So by using this particular equation, we used to calculate the paired sample t-test. Clear? Let's have a glance on one calculation. One simple calculation, okay, it's very easy. One sample t-test, okay. One sample t-test, we are going to do the calculation. So let's see. So here there is an example which I have taken. Let's say we want to test whether the average score of 5 students, okay, the total sample is 5. 5 students in a test differ significantly from the expected mean score. Keep in mind the expected mean score, that is the 50. Okay, the expected mean score is 50 and we want to test whether the average score of 5 students in a test significantly different from that of the expected score of 50. Okay, so here whether the scores of the student is on the one side, 50, that is the expected score, is on the other side, and we are trying to analyze whether there are significant difference between these two. Clear? That is the situation, or that is a statement of the problem. Okay. Student 1, 2, 3, 4, 5. See, for example, the score of the student, which is denoted as X, that is 52, 48, 49, 53 and 50. These are the score of the student. And our expected score, the expected score is equal to 50. Okay, we are trying to find out the significant differences. Okay. Step 1. Find the sample mean. Let's find out the mean of the score. So mean of the score means here we have 52 plus 48 plus 49 plus 53 plus 50, that is divided by 5, isn't it? So here 52 plus 48 plus 49 plus 53 plus 50 divided by 5. We have find out the mean, isn't it? We have find out the sample mean, which is equal to 50.4. Clear? We find out the mean. And now we are finding out the deviations. So how we are finding out the deviations and the square deviation? Let's see. Here this is the same score, 52, 48, 49, 53 and 50, right? These are the same score. Okay, that is on the one side, which is denoted as X. X is the score that we know. Now we are subtracting 50.4. Then what is 50.4? 50.4 is the mean, isn't it? So here we are subtracting mean from the score. We are subtracting mean from the score. So what will be that? 52 minus 50.4, 48 minus 50.4, 49 minus 50.4, 53 minus 50.4 and 50 minus 50.4. That means we are doing the subtraction over here, and then we will get this value, isn't it? Positive 1.6 because 52 is greater than 50. 48 minus 50.4, of course the value will be in negative, isn't it? Minus 2.4, minus 1.4, plus 2.6 and minus 0.4. These are the values that we get when we minus the mean value from the score value. Clear? I think so far so good. Okay. Now we are going to calculate the square of this particular value. That means the square of this particular value means 1.6 whole square. Otherwise 1.6 into 1.6 minus 2.4 into minus 2.4 minus 1.4 into minus 1.4 plus 2.6 into 2.6 minus 0.4 into 0.4. So automatically we will get these values. So the minus value will be taken into positive because minus into minus is positive here. So these are the values that we used to get, that is 2.56, 5.76, 1.96, 6.76 and 0.16. Now we are adding all these. That means we are adding plus, plus, plus and plus, and then we are getting the value, that is 17.2 sigma. That means total of these value we are getting 17.2. That is sigma of x minus x bar the whole square is equal to 17.2. So now we have the mean value, isn't it? We have the expected mean value also here, and also we have the sigma x minus x bar the whole square, that is the squared deviation value also with us. Now we are going to calculate the standard deviation. So what is the formula? S is equal to root of this particular value, sigma x minus x bar the whole square divided by n minus 1, root of. By this we are calculating the standard deviation, which will be 17.2. This is the value. 17.2 minus n, n is 5, 5 minus 1 is equal to 4. So root of 17.2 minus divided by 4, that is equal to root of 4.3, that is 2.07. So we have the standard deviation, that is 2.07. Okay. Now we are going to calculate the T formula. That is the mean value. We have calculated the mean value. What was the mean value? 50.4. 50.4 was the mean value. So we put 50.4 over here and then 50. What was 50? 50 was the expected score, isn't it? 50 was the expected score. So here 50.4 minus 50, that is the expected score, divided by standard deviation, that is 2.04 is the standard deviation, and divided by root of n. N means the total sample, that is 5, and finally we get the value 0.43, which is the t value. We are getting the t value, that is 0.43. Hope it is clear. Let's have a quick glance. First, what did we do? We had the score of the student and we find out the mean by dividing it by the number of samples, and we got 50.4, and we had the score over here. We subtracted 50.4, that is mean, from the score, and we put the square, and then we took the sigma, and by using that value we found out the standard deviation, and then we applied it in the equation, and finally we got the t value. Now let's go for the interpretation. So what is the interpretation with this particular value? Degrees of freedom, I won't explain what is degrees of freedom, we have already explained it in the last lectures. So that means degrees of freedom, that is n minus 1 is equal to 4 over here. At 0.05 level, the critical value two-tailed is 2.776, and here the calculated t value, it is considered as less than 2.776, and hence it is not significant. So here there is no significant difference between the mean sample, between the sample mean and also the population mean. That is the final interpretation. In this way, if you have the mean and also the standard deviation of the sample, by putting it in the equation, you can calculate the t value with the help of all the types of t-test you can calculate. Okay, I hope it is clear. This was a manual calculation. We can use various softwares like R Studio and also SPSS, various other softwares as there. We have already discussed about the advanced software that we could use in the field of social science and education. You can use any one, and we can go for manually also if we have the standard deviation and also the mean value with us. So as far as t-test is concerned, there are certain challenges also that we are facing. That means it is sensitive to outliers. See, for example, if we calculate the t-test value, the mean of the data when we are calculating, see, for example, if the value, a few values or one of the values, we can say if it is extremely high or extremely low, then it may result in the t-test result, isn't it? Then it may affect the t-test results and it may affect the mean value also. Of course, when the mean value is affecting, it will affect the t-test value also. That is quite understood, clear. So here, see, for example, suppose we are comparing the average test scores of two groups. Here, the values of group A is 70, 72, 68 and 70, but one is 120. Here, the score 120 is considered as an outlier, isn't it? So because that is too much extremely high, but we have already discussed about the data transformation in the last classes by using square root transformation and various other methods. If you want, you can go for that, but still, if we are not going for any kind of data transformation, of course it may affect the mean and directly it will affect the t-test value also. So here, mean of group A may becomes much higher due to 120. Because of this, the mean value may be having a huge difference. It may give a misleading impression that group A is performing better as compared to that of the group B. The t-test result may incorrectly suggest a significant difference, even though the most of the students have almost similar score. Even though the mean is almost similar, it may give you a different score, that means a significant score which is not genuinely not significant because of this particular outlier. So that means it is sensitive to outliers. That is also one of the challenges. Next one is it requires normality. The t-test assumes that the data is in each group is normally distributed. If the data is skewed or it is non-normal, if it is like that, the test can give an inaccurate results usually. See, for example, suppose we measure the time, that means in minutes, if we are measuring the time taken by the employees to complete a particular task, group A is 5, 6, 7 and 100 and group B 6, 5, 7, 6, 8. that is the time taken in minutes by the employees in order to complete a particular task. So here groups A's data is highly skewed because of this 100, isn't it? So here a t-test measures normality, but this skew violates the assumptions. But because of the skewness, it may violate the assumption, so the row value might be unreliable. So that is why we can say that it requires normality, and it is very sensitive to the normality assumptions. Also, it requires equal variance. That means homogeneity of variance is required in t-test. The t-test assumes the variance of the two groups are approximately equal. Okay, that means the variance of both the groups are approximately equal, and if one group has much higher variability, then the t-test result can be misleading, isn't it? See, for example, the group score, that is 70, 72, 68, 71 and 69, the variance is approximately it is equal to 3. But here in 50, 90, 60, 80 and 100, the variance is approximately equal to 400. So here group B score vary widely compared to that of the group B. Using a standard t-test without correcting for unequal variances, it may give you certain incorrect significance. That means your interpretation or your value or your result may lead to certain leading to you certain unreliable information. Okay, so that is, it requires equal variance or the homogeneity of variance. And also it less reliable with small or biased sample. See, for example, the t-test relies on random sampling, and small sample size or biased sample reduces its reliability. See, for example, suppose you want to compare the average height of a male and a female. Okay, you want to compare average height of a male and a female students, but you only take 3 students. You only took 3 students from each gender, 3 from male and 3 from female, and the male height is 170, 172 and 165, but female is 160, 158 and 162. You hear small sample size, it can be less stable and it may not represent the population accurately over here. And also you took some biased sample. That means you selected the male, only 3 males who are playing like a basketball team. So usually in the basketball team, we have persons who are having good height. So you took a biased sample over there. You have a gender biasness over there. That means the result should come out like that, like this, like males are having much higher. Males are much higher in height compared to that of the females. So you took a biased sample over there. You took selected persons from the basketball team. So the sample is biased and the t-test result won't give you a generalized result or a perfect or an accurate result which you could generalize. Okay, so that means it is less reliable with that of the small sample or the biased sample. So in conclusion, so here we have discussed about the various t-test and types of t-test, equations also on how to use those equations in t-test. Apart from that, we have also discussed about certain, what to say, outliers and also certain assumptions, certain challenges that we are facing with respect to the t-test. T-test, even though it is a statistical fundamental tool, just like I used to tell you in each and every lecture, we have to use it wisely. Here, it is widely used in research across education, psychology, health sciences and also social sciences, because it is very simple and also it is very simple to interpret so far, isn't it? So that is also one of the major advantages that we used to say with respect to t-test. But here, careful attention must be paid to the assumptions like normality, homogeneity of variances and also sensitivity to outliers. That assumptions also should be very much particular and clear. Apart from that, small or biased samples can affect the reliability of the results. So you should check the assumptions before applying the t-test or consider the alternative method. We have various non-parametric tests also, like Mann-Whitney U-test, like that. We have various non-parametric tests also. You can go for that when the assumptions are being violated over here. Otherwise, if the assumptions are correct, of course, you can go for the t-test. Despite all these limitations, we can say that t-test remains an essential method for making certain informed decisions based on the sample data. Based on the sample data, it gives you certain informed decisions. So that's all about the t-test which we have discussed over here. So here are the certain references that I have kept for your consideration. You can go through it. Certain e-books and Google books are also available in the Google platform. And thank you so much and have a nice day.